This site is actually part of a bioenergy research center, which we haven't mentioned too much as of yet. So I'll just say a little bit about that and the kind of the support that goes into the experimental site. So the site is actually funded by a Department of Energy Bioenergy Research Center called the Center for Advanced Bioenergy and Bioproducts Innovation. It goes by the abbreviation CABI. And it's actually a nationwide center that's hosted at the University of Illinois, but has collaborators from coast to coast that look at the whole chain of bioenergy production and energy conversion into usable products. And the real unique aspect that this center has, there's actually 4 of them in the country, is that we're actually focused on trying to make higher value products within the plant. They have this concept of what's called the plants as factories, where basically the idea is to make the plant into the producer of higher value products, oils and lipids that you can crush and use to make higher value products besides the cellulosic bioenergy sort of potential of it. So earlier when they were asking, why would any farmer want to grow sorghum in Iowa? As of now, it is still kind of a murky situation. But if we're able to develop the technology that goes into changing the amount and concentrating higher values of lipids or oils inside these sorghum stems, we could actually squeeze them out first, sell that product out maybe into a local or more regional market, and then sell the rest of the biomass into the cellulosic energy or other bedding or forage markets. So we're trying to not only diversify the number of plants, but diversify the economic value of the chain here. And right now, it's at a very experimental stage. It's going to take many years to do. It's an experiment that's in just about its 4th year of experimentation so far, that we hope will go for at least another 5 years after the 5th year is done here, and try to really get this thing along the way to know how we can basically grow higher value crops in Iowa. So we do that by growing them in a rotation, as we mentioned in the video. This is a kind of a aerial view of the 4 plots of how they're laid out where the eddy covariance is taking place. And we also have smaller plots. Each one of these is tile drained. We didn't draw the lines in the little orange and green ones here. And we monitor the tile drain on all those. So we get the above ground and below ground kind of components. And the annual crops are rotated again through these 3 plots, whereas miscanthus, which you'll hear about later in this series, is over on the southwest side of things. So relative to Iowa State, the farm is just about 1.5 miles south and west. Here's the location of the site. We call it SABR. It's a Sustainable Advanced Bioeconomy site. And maybe you're familiar with some of the other research projects, and you probably had other videos in this series about some of the other ones around, especially Cobb's is particularly well known, and the agronomy farm is pretty well known to most people that are familiar with Iowa State. So it's actually not too far away from campus at all. So here's another overview aerial picture of what the site looked like around the time that Josh's picture was taken when he put in his slide deck. So we established it in 2019. It's 65 acres, and we're using that eddy covariance technique we mentioned in the video to measure how much carbon, nitrogen, and water are leaving the system to the atmosphere. Then we have some tile drains down below that measure the water flow. We didn't really go over the concept too much of carbon balance. Maybe some people are familiar with it, maybe they aren't. So the main idea is kind of depicted in a diagram here in the bottom right, where you have photosynthesis coming in, with carbon dioxide coming in through photosynthesis in the atmosphere. It goes into plant tissue, and then eventually it'll either, the tissue itself will give off carbon dioxide and respire, or maybe some microbes or other microorganisms will eat that and respire it. And just like I showed with the corn stalk that was around from the previous year, you have to think about this whole thing as a system of losing carbon dioxide and gaining carbon dioxide at different times. Roger went over the main instruments that are in one of these setups. So I just wanted to show maybe another quick image of those with the arrows pointing to the specific names of some of those. And I'll just leave it here for just a second so people can see kind of all the instrumentation that goes into these sort of measurements. And then we can maybe take some questions on those if people have them at the end and how that works. But the main idea is, as the wind blows by these sensors, it can measure very fast changes in CO2 concentration and water vapor concentrations and integrate that into what would be measured as photosynthesis. Rosa mentioned that while we were standing there, it probably took 10,000 data points. If you look at the number of seconds in a day, it's 86,000, and it takes 10 measurements per second. So that's almost 1 million data points per day per plot. Rosa is crunching all those data over kind of a 1.5-year period. And the picture that we have so far, the carbon balance looks about like this. So miscanthus is a perennial grass we started growing in 2019. We have corn and soybean, and then we have sorghum here in green. As Josh pointed out, the corn is planted a little bit earlier. It's the purple line, and it gets more negative quicker. The more negative is in this line, the the more CO2 it's taking out of the atmosphere over time. Whereas the sorghum continued to grow the green line well until the killing frost had happened sometime around the middle of October last year, similar to what we had this year. Miscanthus was still taking up carbon. It actually didn't die in that first frost that sorghum did. And soybean had given up taking up carbon quite a long time before that, and was already just basically giving up the soil respiration in 2019. 2020 is still underway, and we haven't had all the time to process all the data yet, but it looks like a pretty similar picture with sorghum taking up more carbon than the corn did. Miscanthus started out a little quicker this year because as a perennial grew back a little bit faster, but again, you'll hear more about Miscanthus later. And soybean was on a similar trajectory, but maybe a little bit flatter on this line, meaning it's not diving as deep, which means maybe the drought was causing slightly less photosynthesis in that annual crop. It doesn't really appear to have affected the fluxes as much in carbon uptake by sorghum thus far. So we were monitoring the tile drainage flow, but we really didn't have a ton this year. So this is the different plots that we showed, the large ones, and Kate actually just hooked up the small ones when the video was being taken, so we don't have one from those from that cover crop experiment component. But from the big plots, you see the big green, our big blue bars are when it rained, and then the spikes in the dots are when the different plots were giving off precipitation. 25 on this graph would be an inch, 25 millimeters is an inch. So throughout the growing season, we didn't have very many inch plus rains. With the absence of early in the growing season around the middle of May, where we got a big flow event, basically every time it rained, it was just recharging very dry soil. And even this 2-inch rain that we got in September wasn't enough to kick on all the tile drains. Maybe just 1 or 2 of them had one little reading at the time point. So it was very dry, and we didn't have a lot of water leaving the system this year, but maybe we'll have a flush here in the spring, or maybe even a wet fall or wet winter time. Who knows what we'll get. So I just wanted to say thank you to a lot of people that made this happen, of course, for the support that we have from CABI and the Department of Energy. Emily actually spoke up earlier, which I'm really glad. We're definitely very closely collaborating on this project. I didn't put Adina Howe's name in here, but I should have had it in here. She is a collaborator from ABE, also in agronomy, who is measuring a lot of the microbial things that we talked about. Nick Boersma makes the site go. Patrick Edmonds and Jacob Stute also make the site go and really coordinate a lot of those things that we showed. All those shiny tools and instruments really take a lot of expertise to run. And then the university itself, Tim Good and Ken Burns have really made it pretty easy to grow pretty weird stuff in Iowa. And then there's a huge list of undergrads. I didn't even put their name in here who have basically kept all this going that I also wanted to thank while I had the chance. So what other questions did we get, Liz, while I was going through that?
Well, I think you stunned everybody because I don't have any pending questions just yet as they're going through there. So again, feel free to get those typed in. I do have to say thank you to Jalen for letting me know I forgot to hit the recording button. So I did get it going during your presentation there, Andy. So I'll have that for you. And I'll also share with everyone your email so that if they have follow-up questions, they can certainly reach out to you for that.
Excellent.
And maybe pass those along to Josh as they come too. So I had one more question, I guess, of my own. And I think Josh is maybe this part of your research part of it, but how is the economics comparison to corn and soybean? I know there's a limited market for it now, but in terms of inputs, how does that compare?
So we have some collaborators at University of Illinois who are also part of CABI who are using some of the model output that I've created. That they're doing an economic analysis. I'm not entirely sure where that is right now. But as far as like just basic farmer inputs, like I mentioned earlier, with the sorghum requires less nitrogen than corn. You get the same or more biomass for sorghum compared to corn at lower N rates. And then also the seed itself is also not as expensive as it is with corn. I'm not sure as to the exact price points of that, but I have read that it is substantially lower seed price for sorghum compared to corn.
Yeah, there are just not very many commercial sorghum seed options out there, and the market is pretty small around here, so we don't really have good numbers on those. But again, that center that I showed actually includes economists who are looking at those questions more directly. A real big part of this will be whether or not we can get those higher value compounds to be inside the stem and leaves of the sorghum. Basically, you have to think about that as the equivalent of the grain of corn. You get a lot more dollar per pound of a corn grain than you do for the stalks and stems.
Right. Since sorghum is harvested while actively growing, would you expect a nutrient flush in the soil as the roots decay?
I think that's a valid question, but I don't really expect that to happen because our carbon and nitrogen ratios are, the nitrogen content of leaf is kind of slowly decaying throughout the season, and I imagine the roots are probably following a somewhat similar trajectory on that. They would actually have a little bit of exudation that might be coming out with some pretty maybe available nitrogen, but a lot of it's going to be in just an organic matter that's going to take a while to decompose. And as Josh mentioned earlier, the mass of carbon, the mass of nitrogen in the roots of sorghum is about the same as corn. So I don't imagine there'll be a big flush, and we haven't had enough rain to find out yet, but the experiment is set up in such a way that we would actually capture that. Unlike a lot of other experiments, we would actually see that coming through our water monitoring. And if we do, we'll let you guys know.
All right, so keep those questions coming in. In the meantime, I'm going to go ahead and share my screen here that includes Andy's email there. So Andy VanLoocke at iastate.edu. Again, if you attended today's virtual field day for a CCA credit, be sure to get me an email this afternoon by 5 o'clock with your full name, the name you entered to watch, and your CCA number, and I'll get that submitted for you. And our next event is actually in just over a week. It's next Thursday. We're going to tour some of Iowa's varying forests with Dr. Billy Beck and some DNR folks. So we hope that you can join us at 1 o'clock next Thursday. So let's see if any more questions have come in. And I'll put his email in the chat as well in case that was too quick to capture as it was on the screen. All right, and so I know in our discussions yesterday, right now you're in year 3 of implementing growing crops out here of 5 years with the hopes of continuing it on. So maybe in a few years we'll visit back and be meeting in person to check out the sorghum growing out in the field and see what's going on out there.
Yeah, I left the picture of sorghum as my virtual background. It's a striking crop actually to go walk around. I'm glad we got some photos and got some video before they harvested it. They're really anxious to get it harvested the day we were out there. It's amazing to walk in a canopy that is 12 feet tall almost, and as we get better varieties and learn how to manage it even better, it might grow even taller. It's an impressive crop, and there's nothing like going out and seeing these new things at kind of a field scale. Seeing them in a virtual video, which was very nice. It's fun, but I would really like to have people out and see it in person.
Yeah, so we'd love to help with that as well, and maybe even get a few more sites around the state so people can see it maybe growing in their own areas as well. So with that, thank you both, Josh and Andy, for participating today, and everyone who logged in. Thank you so much. We look forward to seeing you in future field days, and stay warm out there today.